So I just covered the differences between climate and weather, the greenhouse effect, and some basics of how our global climate system works. Um, if you're thinking about climate change and trying to understand the evidence, there are some different relevant questions. So, first thing is to know, is it occurring? Are humans causing or contributing to it? Is it bad? Should we do something about it? And what should we do? And these are all important things to discuss. In the media, a lot of times we focus on certain parts of this and not all of this. And so it's important to think when you hear news stories, are they talking about the most important thing? Should we weigh different sides equally? Or should we weigh them based on the number of scientists that agree with one side or the other? And these are important things to think about. So we're going to get into the evidence for climate change. And the first thing to think about is natural climate variability. So if we're wondering whether the climate is changing and how fast it's changing, we need to know what past climates have looked like and look at our climate record. And so we know that the climate has varied on scales of decades, centuries, and even millennia. And we have data that supports this variability. Some of the most important data we have are from ice cores. They can be collected from glaciers. And as these glaciers are put down, glaciers are permanent ice, or at least relatively permanent. And each year, a layer of ice is put down from precipitation, and it traps little bubbles of air in it. And these provide a very important history of what the atmosphere was like and what the climate was like in the past. And so the air bubbles trapped in the ice can be analyzed for atmospheric composition. So we can see what concentration of carbon dioxide was in the air in the past, for example, using these air bubbles. And we can also look at what the temperature would have been like that year. So it reveals this information about past atmospheric conditions, and we can reconstruct past temperatures and patterns. The most important ice core data we have is from Vostok, which is in our Antarctica. There are lots of other places where we have good, reliable ice core data, but Vostok, because Antarctica is so stable and has had ice on it for so long, this is our longest climate record that's from ice. And this record goes back 420,000 years, and these pictures show pictures of the ice cores. And this hallway shows all the different ice cores that they've collected. And they've drilled down to get these, and they can drill down very far, and it's a very thick ice sheet. So it has 420,000 years worth of reliable layers that we can reconstruct past climates with. So this shows some of the Vostok ice core data. So this shows temperature variability here. And this is thousands of years ago. So it's a little bit backwards. So this 0 here shows the present day, and then it goes back in thousands of years ago. So this is 50,000 years ago, 100,000 years ago, on to 400,000 years ago. And so they've used isotopes to reconstruct the temperature. They've been able to look at the air bubbles and look at the carbon dioxide concentrations in the past, and they can also look at dust, and so they can melt little pieces of ice and weigh out how much dust was in the atmosphere at different points. So we see here that there are big variabilities in temperature in the past, and the climate is changing now, and it has changed in the past. So no one is saying that this is the first time the climate has changed. What we're saying is that the current climate change is occurring very quickly. So you can see there are all these changes, but they happen over a long period of time. What we can also see is that there is a good correlation between carbon dioxide and temperature variability. So when carbon dioxide is high, the global temperature tends to be high. When carbon dioxide is low, the global temperature seems to be low. And it's not a perfect correlation, but you can see that it's pretty tight. Every time there is a large peak, in one of these graphs, there's a large peak in the other. However, you can see that dust concentration does not have a tight correlation with temperature. It plays some part, but it is not as big of the puzzle as carbon dioxide is. So we see that from the ice core data, drastic changes may have occurred over a short period of times in the past. The Little Ice Age was a historical period of climate change that had destabilizing effects on human populations. In the Little Ice Age, which you can see here, temperatures were much colder than they had been. And temperatures dropped, crops failed, fish migrations changed, shipping lanes were blocked with ice. There were major economic problems associated with this change in climate. So people are vulnerable to changes in climate, and it can affect our economic systems. So why has the Earth's temperature fluctuated over time? Some of it has to do with changes in output of energy by the sun. There are sunspot cycles, solar magnetic cycles. We also get changes in atmospheric composition. Very large volcanic eruptions can emit lots of sulfur particles, which are very reflective, and they can reflect the sun's light back into space and cause the Earth to cool somewhat. So this again shows the correlation between carbon dioxide and temperature from the Vostok ice cores. And this puts them together, and so you can see the temperature. This is in Kelvin, which has the same basic scale, or the same difference in degrees as Celsius does. And there's carbon dioxide concentration over here on the right. The Earth is actually currently in a relatively cool phase characterized by the formation and advance of glaciers. We've also had a very stable climate. So you can see in the past it jumped up and down a lot. The Holocene includes the last 2,000 years where we've really seen human civilization and technology explode, has been relatively stable. There have not been crazy large jumps or dips in this period. You can see that it looks much more stable than any of the other recorded time periods. And this is the only period where we know that human civilization can do really well and have lots of economic progress. This shows the last glacial maximum, which was about 20,000 years ago. And so you can see glaciers came all the way down into Ohio, Indiana, Illinois, and Iowa. And that's a big part. These are kinds of things when the global temperature dips down very far, we get the advance of glaciers. So we've also been trying to measure carbon dioxide, and so I showed that there was data in the Vostok core, and so the next video we'll talk about more recent carbon dioxide records.